Welcome to the video on the second derivative. So first we'll talk about what second derivatives are. The second derivative is the derivative of a derivative. So your notation would be d squared y over dx squared, or f double prime of x. And your second derivative will tell you the concavity of a function. So if your second derivative is greater than 0, it's positive, so it's going to be like a smile, concave up. If your second derivative is less than 0, it's negative, so it's going to be like a frown. It'll be concave down. When you're taking derivatives, your degree of your function will decrease with each derivative. So if we look at this image here on the right, our original function, f of x, is this red line, and it's a cubic function. Then when you take the derivative, it'll become a quadratic function. So your f prime of x is a squared function. And finally, your derivative of that would then be a linear function. So your f double prime of x, your green function, is linear. So to graph your derivatives, you would start by entering your original function into y1, like shown in this picture here on the right. You enter your first function, and then in y2, you go to math, nderiv, and enter d dx of y1, where x equals x. So you could do your d dx, where x equals some number to find your derivative at a certain point, but we want to graph the entire function, so we're doing the derivative of the original function for all values of x. So that's what you enter into y2, and to enter in y1, into your derivative, you'll hit vars, yvars, function y1. Then in y3, you'll go to math, nderiv, and then you'll take the derivative of your derivative, so of y2, where x equals x. And to enter y2, you go to vars, yvars, function y2. Then finally, you'll hit graph, and it'll look like this image here, where y1 is your original function. So our original function was a squared function. So that's y1. y2 is your first derivative. So when you take the derivative of a quadratic, you then have a linear. So that's y2. And then y3 is your second derivative. And in this case, it's constant because the derivative of a linear function is a constant. So that's how you would graph your derivatives. So now we have our first IB practice question. It says a function is given by the equation f of x equals 3x squared minus 2x plus 4 cosine of x. Find the first and second derivatives. So for our first derivative, we have several things being added, so we can take the derivatives of each of them individually. So our derivative of 3x squared, we do 2 times 3, which is 6, x, and then we decrease the degree of the function by 1. So it's just 6x minus 2. And then we have the derivative of cosine of x is negative sine of x. So we'll have negative 4 sine of x. So that's our first derivative. Our second derivative, f double prime of x, will equal our derivative of 6x is just 6. Then the derivative of a constant will go away. And then our derivative of negative 4 sine of x, we can pull the constant out front. And then the derivative of sine of x is cosine of x. So here are your first and second derivatives of that function. Now we have our second IB practice question. It says, find dy dx and d squared y dx squared for the function y equals 3 sine of 2x cubed. So we're finding the first and second derivatives. So dy dx equals, for this one we have a function inside of a function, and then we also have a function inside of that function. So we're going to need to use our chain rule. So 3 times 3 is 9. So we have 9 times sine of 2x, and then we'll decrease the degree by 1. And then we'll multiply that by the derivative of this inside part. So the derivative of sine is cosine. So we'll have cosine of 2x. And then we need to multiply that by the derivative of the inside of that one. So the derivative of 2x is 2. So this simplifies to 18 sine 2x squared cosine 2x. So dy dx equals 18 sine 2x squared cosine 2x. So there's our first derivative. And now we need to do our second derivative. So we have two functions being multiplied by each other. We have this function here and this function here, so we need to use our product rule. So d squared y dx squared equals derivative of the first. So 18 times 2 is 36 sine 2x to the first power times the derivative of sine of 2x is cosine of 2x, and then the derivative of 2x is 2. So we have derivative of the first times our second, so cosine of 2x will stay as it is, plus the first, so we'll leave our 18 sine 2x squared, times our derivative of our second. So the derivative of cosine is negative sine, and then the derivative of our 2x is 2. So now we can go ahead and work on simplifying. So this will equal, we'll have 36 times 2, which is 72. And then we have sine of 2x. And then cosine of 2x times cosine of 2x is cosine of 2x squared. Then plus, we'll have 18 times 2 is 36. And then we have sine of 2x squared times negative sine of 2x. So we'll have sine of 2x cubed, and then this is going to become negative. So our d squared y dx squared equals 72 sine 2x cosine of 2x squared minus 36 sine of 2x cubed. So here's our second derivative. So in summary, a second derivative is the derivative of a derivative and is written as d squared y dx squared, or f double prime of x. It tells the concavity of a function. If f double prime of x is greater than 0, then f of x is concave up. And if f double prime of x is less than 0, then f of x is concave down. And the degree of our functions will decrease with each derivative. And to graph derivatives on a calculator, you'll enter the function into y1. Then in y2, you'll go to math and deriv and enter d dx of y1, where x equals x. And in y3, you'll go to math and deriv and enter d dx of y2, where x equals x. And then you'll hit graph to graph your function, first derivative, and second derivative. That's all for this video. Thank you for watching.